Now we are going to see the refraction. Just now, previously we have seen the refraction of a light through a simple glass slab, right? There is a refraction of a light through a simple glass slab. Nothing was there, nothing spherical surfaces were there. It was only a plain simple glass in between of a light rays. Now we are going to learn how the light rays will pass through the lenses and what exactly happens. Yes, so in previous unit, you have seen about the concave and convex mirrors and how the light rays passes through these mirrors. What are the different types of images you get through these mirrors, right? Similar thing we are going to learn in case of these lenses. Okay, now let us see what are these lenses. First of all, you all know what are the spherical lenses, correct? How these spherical lenses are formed? Yes, you must have seen that there are two different types of spherical lenses. One is a convex lens and another is a concave lens. So you can see here that this is a convex lens, right? Why it is called as a convex lens? Yes, it is a converging lens. That is right. So this convex lens is having the surfaces. Okay, you can see this right side surface and this left side surface. They are both bulging outwards, isn't it? So when these kind of lenses, now if you just imagine that there are two spheres. Okay, if you take this sphere this side and this sphere this side, okay, just ignore my diagram. If you take the two spheres which are attached to each other, and if you take their two surfaces together which are bulging outwards, then this type of a convex lens is formed. Getting it? This type of convex lens is formed
Yes,
every
ma'am.
time. So you have to see, or you can just imagine how con how these convex lenses are formed. And the similar thing happens in case of concave lens also. So I just want to tell you the different, what you can say, the terms related to these concave and convex lenses. Now, who will tell me what is this C here written? Yes. What is the C written here? Capital C? Very good. This is a center of curvature. Now, why there are two center of curvatures coming here? If this is only one lens, why there are two center of curvatures? Yes, but because it's a lens, but just now what I told you, this lens is made up of two different spheres, isn't it?
Okay.
Yes,
Yes,
so when
ma'am.
it is made up of two different spheres, so each sphere will have its own center of curvature, correct? So here
Yeah.
is the one and here is another. And what is this capital F here? Yes, it's a principal focus. Okay, what is principal focus? What is the definition? See, principal focus is the point on which all the rays are going to come and converge on one point. That is called as a principal focus. So if you imagine that the rays are going to come from this side, okay, in this convex lens, they are going to come and get converged on one point. So this point is called as a principal focus. Got it? This is called as a principal focus. And what is this P here? What is pole?
Pole.
What is it, pole? What is the definition? It is the center of the lens, right? The center point of a lens, or you can say the center of a mirror. In case of mirrors, if you have seen, that is the center of a mirror. In case of lenses, you can also call it as an optical center. Okay, this P can also be written as capital O in case of lenses. It is called as the optical center of the lens. Got it? And what is this line? This is a
Principal.
principal axis, which is the imaginary line passing through the center of the lens and center of the curvature also. Okay. Now, if you take this convex lens, remember that if the light enters a triangular prism, now you all must have seen the prisms. The activity also you must have seen, right? How the light rays are entering. If the white light is passed, what kind of light comes out? If the white light is passed through the prism, yes, what? A rainbow
Um,
colored refraction, do you see?
yes, yes,
Vibgyor.
yes.
Vibgyor, yes.
Vibgyor.
So, if you remember that if the light enters in a triangular prism, now this is not a white light, it's just a single beam of light. Okay? If you are trying, yes, if you are trying to beam of light, it will bend towards the base. Now you can see that this is one prism kept Okay, and this is blue colored, another prism kept one on each other this way, right? So this can form a type of a convex lens only, isn't it? So you can see whenever you are trying to focus the rays of light, they are going to come and they will be having this kind of refraction. Getting it? What will be the refraction of the light rays here? They are going to converge, right? So a convex lens will bring rays of light closer to each other. So it is a type of a converging lens. What do you mean by converging? Yes, all the light rays are going to come on one point. They will be collected on one single point. Okay, that is called as a converging lens. And in case of concave lens, if you remember that if the light enters a triangular prism, now if you imagine that the prisms are kept in this way, okay, you can see the pointed ends of the prism are kept together. So this is the base of the prism and it bends towards the base. So you can see if you try to pass the light rays through the concave lens, the light rays are going to get refracted in this manner. So what is the difference between these lenses now? Diverging. What do you mean by diverging? Yes, these light rays are going to move away from each other. They are not going to converge on one place. Got it? So a concave lens will push the rays of light away from each other. So it is called as a diverging lens. Got it? Okay. Let me tell you one activity here. There is the activity in the textbook. The activity is 10.11. I will just present the textbook and will let you know about this. Just a minute. Okay. So this is the activity here if you see. See, what are we learning here? Convex lenses are the converging lenses, isn't it? So these convex lenses are trying to collect all the rays which are coming inside and they are trying to focus it on one single point. So if you see here, you are going to, everyone knows that we should not look at the sun directly or through a lens. So what will happen if you are looking directly to the sun? You may damage your eyes, isn't it? So in this activity, what you are going to do, you are going to take one convex lens in your hand and direct it towards the sun. If you try to focus the light from the sun on a sheet of a paper, what will you get? You will get a sharp image of the sun onto the paper, isn't it? Many of you must have tried this. Yes, even if you have a convex lens with you, you try to do it afterwards, after the classes are over. Try to do this. So what happens is, if you take the focus of the light from the sun on a sheet of a paper, you will obtain a sharp, bright image of the sun on a paper. And then if you hold the paper and the lens in the same position for a while, what happens to it? The paper begins to burn, which will produce a smoke. Why this happens? Because all the light rays which are coming from the sun, those light rays are going to get converged on the piece of a paper, right? And that is a light energy which is coming and getting collected onto the paper, and because of this the paper starts catching a fire. It may even catch a fire after a while. If you try to continue this activity, it may catch a fire. So why this happens? The light from the sun will constitute parallel rays of light, isn't it? So whenever you are trying to converge it by the convex lens at a sharp bright spot, the bright spot, whatever you got on the paper, is the real image of the sun, isn't it? You must have seen whenever you see the bright spot on the paper, that is actually the image of the sun. Okay, that is a real image. What is the difference between a real and a virtual image? Who will explain me? Yes? What do you mean by a real image? So real image is what? The image you can take it on any of the screen, on the wall or on a paper, right? And virtual image you cannot take on a screen. So virtual is what? Which you can see yourself in a mirror. That is a virtual image that you cannot take it on a screen. Right? Here you can see that you can paper. Right? So this is a type of a real image. So the concentration of the sunlight at a point will generate a heat, and that is why it causes the paper to burn. Getting it, everyone? Yes, have you understood? This may come as with the MCQ point of view, the question may come regarding this, so you have to write the proper answers. Now, there is one more thing I want to tell you regarding the effective diameter of the circle. Now, just read this part. A ray of a light through the optical center. Now, what is the optical center? Just now I told you. Yes, what is the optical center? Yes, I showed you into the diagram just now on the slide. What is the optical center? It is the center of the lens. Okay, you call it as a pole in case of mirrors. So optical center and pole both are same. So a ray of a light through the optical center, that means the center of the lens, okay, passes without suffering any deviation. So just now when I showed you on the slides, what happened in case of convex lenses? The light rays will bend and they will get converged on one point. And in case of concave lenses, what will happen? The light rays will again bend and they will diverge. Right? But the light rays which are going to pass through the center of the lens, they will not suffer any kind of a deviation. They will just pass in a straight line. Got it? So the effective diameter of the circular outline of the spherical lens is called its aperture. There is one more definition here. Afterwards also you can write it down. You can just mark it here. The effective diameter of the circular outline of the spherical lens is called its aperture. Aperture means whatever the diameter of that particular lens. Got it? That is called as a aperture. Okay, now let us move ahead and see what are the rules of refraction in lenses. Now you must have seen the rules whenever you are drawing the ray diagrams in case of mirrors. You must have followed certain rules, right? So in the same way, you are also going to remember these rules whenever you are going to draw the ray diagrams regarding convex and concave lenses. Now let us see what are those. First of all, in case of this concave lens, you will remember that incident ray and a refracted ray. What is the incident ray? First of all, you tell me, is there any difference between these incident ray and a refracted ray? What are these rays? Incident means what? A ray which is going to hit on the surface. Okay, this is called as an incident ray, which is going to enter into the lenses. And what is a refracted ray? These light rays are going to pass through these transparent substances and they are going to come out. Isn't it? Whatever it is, they are going to diverge out, right? This is a concave lens, so they will diverge. So these are called as refracted rays. Getting it, everyone? This is an incident ray which is going to hit the surface. And these are the refracted rays which is going to come out of the surface. Okay? Got it, everyone? Yes. Okay. So just remember now, the first rule is parallel to the principal axis. What is an incident ray? Incident ray is always parallel to the principal axis. And what is a refracted ray? It will pass through the focus. Now just remember one thing. Just now we have studied when the rays are going to come and hit the concave lens, they will be diverging, right? They will move away from each other. But why then this dotted line? This dotted line is for our reference that if you try to extrapolate this line towards the backside of the concave lens, then these rays are going to meet at this focus, principal focus. Got it? So the incident rays which are parallel to the principal axis, so the refracted ray which are going to get diverged, they will be passing through this focus. Understood till here? Have you understood this ray diagram of the concave lens? I'll repeat one more time. Incident rays, they are parallel to the principal axis. Okay? In a concave lens, these incident rays, when they will be passing through, these refracted rays are going to get diverged. Okay? They will not meet at one point. They will move away from each other. But If you try to extrapolate backwards, okay, these rays, if you try to extrapolate backwards, you will see that they will get focused on one point, or they will get collected on one point. That is called as a principal focus. Now, the rule for convex lens. Incident rays which are parallel to the principal axis. So these refracted rays are going to pass through the focus which will be there in front of the lens. Okay, have you understood the difference between convex and concave lens? Now here you can see these incident rays are parallel to the principal axis. So what we have learned in case of convex lenses, these lenses are going to converge the light rays, isn't it? They are going to get collected towards one point. So this point is the focus point where you can see all the rays are going to get collected. So they will pass through the focus. Second rule in case of concave lenses, the incident rays which are passing through the focus, right? Now, just now we have seen the incident rays which are parallel. These are the another type of rays which will be passing through the focus directly, right? So the refracted ray will be the parallel to the principal axis. You can see here. There are some rays which are going to be in this direction also, isn't it? So these incident rays which are going to pass, they will be passing through the focus, but whenever they will be refracted, they will be parallel to the principal axis. Got it? And another second rule in case of convex lens, the incident ray which is passing through the focus, the refracted ray will be parallel to the principal axis. So here, if these incident rays are coming through the focus from this point, when they will hit the lens, the refracted ray will be parallel to the principal axis, and another rays which will be coming from this side will be parallel to the principal axis. Everyone got this? So we'll remember the rules one more time. Let us see this rule in case of concave lens first. Okay, the first rule in case of concave lens is the incident ray. Now whatever the incident rays which are going to come and hit the surface of the concave lens, okay, first of all these incident rays will be parallel, right? Whatever the rays which are coming, they are parallel to the principal axis. Got it? But what will be happening in case of these incident rays? We all know that they are going to get diverged. They will be diverging lenses. But if you try to extrapolate these rays to the backside of the lens, you will see that they will get collected onto one point. Okay, that point is called as a focus. So these rays will be passing through the focus. Here on the other side, they will be refracted, they will be diverged. But on the back side, if you see on this side, they will be passing through the focus. Okay, next one. Second rule we'll see in case of concave lens only. What about concave lens? Again, the second rule, another light rays which are going to pass through the focus from this side. Now the rays, all the rays which will not be parallel, right? There will be some rays which are going to come in this direction also. So the rays which will be coming in this direction, if they are going to pass directly through the focus, the refracted ray will be parallel. So if you try to extrapolate this, they will be getting collected towards the focus here, right? But the refracted ray will be parallel to the principal axis. Okay, next. In case of convex lens, we will see the rays which are parallel to the principal axis are going to get converged onto one point. That is the focus, right? So the rays which are parallel to the principal axis will pass, the refracted rays will pass through the focus. And another point regarding convex lenses, the incident rays which are passing through the focus, okay, these rays are going to come in this direction. So towards this side, if these rays are going to pass through this focus on the left side, they will be shown as a refracted rays which will be parallel to the principal axis. Okay, now clear till here? Yes, if you remember these two rules regarding convex and concave lenses, the ray diagrams will be easy for you to draw. Right? Now we are going to draw the ray diagrams for convex lenses for various positions of the image. I want you all to take the paper or a notebook in front of you and start drawing these ray diagrams, everyone. So these two rules you have to follow regarding convex lenses. Okay, we are going to have it in case of convex lenses first. Parallel, first rule, the incident ray when it is parallel to the principal axis, the refracted ray will pass through the focus. This is the first rule, right? And second rule is when the incident ray will pass through the focus, the refracted ray will be parallel to the principal axis. Okay, so it is vice versa, you can see. Now, you can draw this first, a lens. First you draw the convex lens and draw the principal axis and show this center of curvatures and principal focus. We are going to keep the object at infinity first. Right? This is the first rule we have to follow initially. Now, if your image position, if you are keeping the object at infinity, we don't know where we are keeping the object, right? The object will be at infinity. So this is a position of the object where we are keeping the object at infinity, right? That is why here in this ray diagram, we are not able to see where we have kept the object. So object is at infinity. Now where you will get the image at focus, why the image will be at focus? Yes, so when incident ray is parallel to the principal axis, you see that the refracted rays are getting collected towards the focus, right? And the image size will be point size because all the rays are going to get converted on one point only. So the image will be highly diminished, you can say, or it will be point sized. And what is the image nature here? It will be real and it will be
real and inverted.
Okay, there is one more thing I want to tell you regarding this. Now here we don't know where we have kept the object, right? The object is at infinity. But then how did we come to know the image nature? Whether it is real or inverted? Why we can say here that the...
Ma'am, because it is behind the mirror, behind the lens.
It is behind the lens, but one thing you have to remember is that whenever the object is kept at infinity, that means the length is more, right? So the image is real if the distance of the object from the lens is greater than the focal length. Got it? What is the focal length? Yes, can anyone tell me what is the meaning of focal length? The distance between center of curvature and the pole is the focal length. So if you are keeping the object at a distance which is more than the focal length, then you are going to get the real image in case of convex lens. Okay, so this rule you have to keep in mind. Okay, so this is the first ray diagram of the object when we are keeping it at infinity. Okay, the object is kept at infinity. So we are going to get the image here at the focus, which the size of the image will be highly diminished or point sized, and the image is going to be real and inverted. Okay, done till here, everyone?
If you like our videos, do share them and subscribe to our channel. If you want awesome quizzes, write to us. Keep watching and keep learning with Walnut.